right, we have one last idea to consider in section 1.3, and that is looking at when could a table represent a linear function. And it turns out that we can take advantage of this idea of constant change that's a property of linear lines to figure that out. So what you need to do is if you're given a table, you need to compute the average rate of change or the slope for all pairs of points in the table. So if we look at this example down here, we would find the slope for these 2 points, these 2 points, these 2 points, and these 2 points. So you have to do a couple of calculations there. If all of the pairs of the numbers in the table give you the same slope or average rate of change, then the function is linear. Okay, and that's because the slope of a linear function or a line is constant. All right, so let's take a look at how we would do that here. So we have y equals f of x. We want to find the slope for that pair, this pair, this pair, and this pair. So m is going to be y2 minus y1, so 11 minus 10 over x2 minus x1, so 55 minus 50. That gives me 1/5, so that looks good. This next one, so I have 12 minus 11. We subtract y2 minus y1, and then x2 minus x1, so 60 minus 55 equals 1/5. Okay, this one here is going to give me 13 minus 12 over 65 minus 60. So that's 1/5, so another 1/5. And then the last one here, 14 minus 13 over 70 minus 65. So that's a 1 in the numerator and a 5 in the denominator. You can certainly use a calculator. I would ask on your homework and on the exam that you show at least what it is that you're subtracting and dividing there. But you could certainly just punch that in the calculator to get this final value, but you'd want to show this step as well. All right, so could this table represent a linear function? And the answer to that is yes, because our slopes are the same. In other words, our slopes are constant. All right, so I would like you to go ahead and try that for this next problem down here. So go ahead and pause the video, give that a try, make sure you feel confident with those calculations. And let's come back and take a look at that. Okay, so I went ahead and wrote out what all of those would be, and then let's just go ahead and make our calculations here. So 3 minus 1 is 2, 55 minus 50 is a 5. 6 minus 3 gives me 3 in the numerator and a 5 in the denominator. Uh-oh, those two aren't the same. So it turns out that you could actually stop at this point because these two are not equal, okay, which tells us right away that our slopes are not constant, they're changing, so therefore this isn't linear. But if you calculated all of these, I'm going to go ahead and give you the answers just in case you're wanting to check that out. Okay, and so your answer here, so you've got 8/5 and 1/5 for the last two sets. Your answer here is going to be something along the lines of no, not linear. Because the slope, or the average rate of change, changes. In other words, it is not constant. Okay. So if you're given a table and asked, could that function be linear? This is what you're going to want to do. You're going to calculate that slope or average rate of change for all the pairs in the table. All right, that is the end of section 1.3.